just do a close-up of the brain. Yeah, like real close. Okay, so when you look at the brain itself, the most evident part of it that you see and what you think of as the brain typically is the cerebrum. And the cerebrum itself has two hemispheres. The tiny or little brain has different characteristics that you see below, also has two hemispheres, and that's called the cerebellum. So let's talk about the features of the cerebrum. We see the bumps and the valleys. So the bumps are known as the gyri, and one singular would be called gyrus, and one valley or groove that you see is known as the sulcus, and so plural we call them sulci. There are a couple of features here with that sulci and gyri, but before that I want to talk about the lobes themselves. So this is the frontal lobe, this is the parietal lobe, this here is the occipital lobe, and on the side is the temporal lobe. If I were to open up the temporal lobe, I would see different type of structure within, and that internal tissue would then be known as the insula, and that is now considered another lobe as well. So let's talk about the dividing features. So what is going to divide sagittally the hemispheres of the cerebrum is known as the longitudinal fissure. There is one sulcus that you could trace from one end of the lateral side to the other end. I cannot do that if I try on any other sulcus, and that one is known as the central sulcus. So the gyrus that is anterior to that is known as the precentral gyrus, and the gyrus posterior to that, which is this one here, is known as the postcentral gyrus. And in lecture we talked about how important they were for motor and sensory processing, okay? So when we look at the actual internal view, now this is one lateral part of the brain, but we're looking medially, okay? So now if I were to have a real brain here and go through the longitudinal fissure, which is a deeper groove than a sulcus, I would come to a place where I would see, oh, they're both attached. And that communicating fibers that attached both of the regions, I'm going to use this one, is known as the corpus callosum. And I like to say C for corpus callosum because it kind of looks like a C, okay? Now, my landmark typically is this intermediate mass that sits within this entire region. Now, if we were to see the real brain, there would be several gaps or spaces in different areas or locations here, and those are known as the ventricles. The ventricles are best seen if I were to take kind of a mold of all that, just the chambers, and pull it out. And on Blackboard, as well as this image here, is where you can see the ventricles really well. And here they are. So each one of right below the corpus callosum is a cavity, and this is one view, and this is a lateral ventricle. There's also the lateral ventricle on the other side. So when we're coming down here, we have what's known as the cerebral aqueduct that gives rise to a little more deeper region here, closer to the cerebellum and the midbrain itself, and that is known as the fourth ventricle. So the fourth ventricle is represented over here. And then in between the lateral and the fourth we have the third ventricle, which is not clearly seen on this view because we can't really see a gap. But when we put the brain back together, we will see a little bit of a gap if I had my cerebellum in here. And it tends to be sometimes a little more complicated. And it tends to be visualized better on this view to where there's a gap right in that junction, okay? And on this view of just the mold area, that would be the third ventricle here, okay? So that is the ventricles. Now let's continue on with the littler structures of the brain itself. So I'm going to utilize this one, corpus callosum, and I had to stick this pituitary gland on here, which is a dangly area on the, or dangly organ on the anterior side of the brain. How do I know it's anterior versus posterior? Well, I want to look at the direction of my pons. The projection is towards the front or the anterior. If I forget that, I also want to look at the direction of my C, okay? And if it's a backward C, then you want to know posterior doesn't look like the curved part, okay? That's also another indication of anterior versus posterior. The stalk that the pituitary gland comes off of is known as the infundibulum. Another word for pituitary gland is hypophysis. You pick the one you can spell. And right above that region is the hypothalamus. Well, if that's the hypothalamus, I know that the region above that, which is kind of labeled as 19 on this particular brain model, is known as the thalamus, okay? And above that would be the epithalamus. So on the opposite side, which is labeled as number 23 on this brain model, is the pineal gland. And that is a frequently missed question with the pituitary. Pituitary is a dangly structure that comes off of the anterior side of where right above, I mean, there's a stalk and then there's the hypothalamus. Pineal is just a smaller structure pointing outward a little bit on the posterior side, okay? So this is the pons, and then this is the medulla oblongata. Now if I look a little more to the lateral view and more inferior, I'll see some of the cranial nerves that are on here. But the best way to view the cranial nerves is when we put this back together and see them in this direction. Olfactory nerve, you can see, and it's also known as the bulb up top and the tract, which is the actual nerve itself that you could see. The next one is optic. I could see the optic nerve, and chiasm is right where it crosses, because we're going to cross and then go all the way to the visual cortex via the thalamus after. So this optic chiasm is directly underneath the pituitary gland on this view. So if someone has an enlarged pituitary adenoma, one of their first symptoms is visual disturbances. And you can see how that happens because it's right there at the optic nerve. So then we have other structures that are coming off, or other cranial nerves that are coming off the pons and the medulla oblongata, and you can see them better on our view on Blackboard. What page we're on? Oh, this is Olivia's, isn't it?
Oh no, that one's there.
Okay. So I tend to like this one because you can see clearly where the nerves are. And so to start you out, we have the olfactory bulb, the optic nerve, the optic chiasm, and you want to do your entire mnemonic this way. So because we are recording, you should remember your mnemonic is O, to touch and feel, very good, velvet, aha, and that should be able to trigger your memory on that. So switching gears to the brain again, and let's look at the cerebellum. So with the cerebellum, we have different type of folding. There's not gyri or sulci, they're called folia. And with the folia, you could see that if we divided these two, they line up this way, and we can see that there's a little worm-like structure right here at the junction of the hemispheres. And that worm-like structure is called the vermis. The vermis. There's really nothing else that looks like that. And okay, well, I'm not adding things. At least y'all know what's on the list. Okay, so the tree-like thing that you see on the cerebellum is known as the arbor vitae. People call this the little Brussels sprout, or I like to look at it as broccoli, whatever vegetable you want. That's what it is. Okay, arbor vitae, tree of life. So one structure that is particularly seen underneath this pituitary gland is right here, and there are two of them, and they're known as the mammillary body. The mammillary body.